Oh, hey, I didn't see you there. Welcome to my lab. My name is Tracy. You may know me as a fellow insomniac and ASU material scientist. Today, we're going over the processes of spin coating and UV-Vis spectroscopy. First, we'll prepare our samples using varying concentration solutions of polystyrene and toluene to deposit as thin films. Next, we'll be using UV-Vis spectroscopy to analyze the thickness of those films. It looks to be a swell time. Let's go!
The underlying mechanics behind the spin coating method relies on three basic variables: concentration, viscosity, and angular velocity. These determine the thickness of the film.
So here's our equation for thickness. Since concentration and viscosity are in the numerator, the higher their values, the thicker the film will be. On the other hand, angular velocity is in the denominator, and a high spin coater speed will contribute to a thinner film.
First, the polystyrene pellets must be crushed or chopped to maximize the surface area to allow for faster dissolution. The volume of toluene is measured with great care, taken to ensure the precise amount is added to the vial. After the polystyrene is chopped, it is added to the toluene in the vials. Next, we take the vials to the vortexer to speed up the dissolution even more.
One eternity later.
Now that the polystyrene is thoroughly dissolved, the samples are prepared for spin coating. For the substrate, we will be using thin squares of ultra-smooth sapphire using chem whips. The sapphire plates are carefully whipped down, and one is gently placed into the spin coater, being sure to have barely visible squares facing up. The spin coater is programmed to run in 4 stages per iteration. These are the start-up, deposition, spin, and the spin down stages. The start-up stage gets the sample up to the desired spin rate. The deposition stage is when the solution is deposited into the sample. The spin stage when the sample is coated, and the spin down stages is the sample slowing to a stop. To deposit the thin film, a controlled amount is dropped into the spinning substrate during the deposition stage. After other solutions have been deposited on their substrate, the samples are placed into a desiccator to draw.
UV-Vis spectroscopy is the measurement attenuation of a beam of light after it reflects or passes through a sample surface. The UV spectrum consists of wavelengths from 10 nanometers to 400 nanometers. The visible spectrum starts at 400 nanometers and goes to 700 nanometers. The UV-Vis spectrometer consists of 2 light sources, one for UV and one for visible light, a detector and a readout. When a sample is exposed to certain wavelengths, the light is absorbed and the electrons in the material are transferred to a higher energy level. This absorption results in less light being reflected, and that difference is noticed by the detector. After both the UV and the visible spectrums are analyzed, the readout outputs a graph of absorbance versus wavelength.
After the spectrometer has been started, warmed up, and set up in the reflection configuration, a sample is secured on a non-transparent material, allowing no light to escape the chamber except to contact the sample. The sample was carefully placed inside the spectrometer, and then the cover is closed. Safety glasses must be worn while the spectrometer is actually in operation, as the UV spectrum is harmful to the eyes. During operation, The spectrometer starts at the red end of the visible spectrum and gradually shifts the wavelength toward the UV over the specified amount of time. After the spectrometer has completed the cycle, a full absorption versus wavelength plot is visible on the computer screen.
Thank you for viewing our presentation on spin coating and UV-Vis spectroscopy. Be sure to like and subscribe for more premium ASU MSE content. Thank you, and good night. Guys. Hey, guys, I'm still in here. Hello?